If two chords intersect in the interior of the circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. Product means multiply. So what this is saying is that if I multiply the pieces of these chords together, multiply the piece of this chord and multiply the pieces of this chord, then those answers to those multiplications should be the same. So what you're going to see me write this as is part times part equaling part times part. Or sometimes you'll hear me say piece times piece equals piece times piece. And that's going to be the formula that we're going to use on this. There's going to be kind of two main formulas that you're going to see us look at here. This is one of them. So this is when everything is inside the circle. If you look ahead in your notes, you'll see the others are when we're outside the circle. So if we're ever inside the circle, this is the formula you're using. Part times part equals part times part. And you can see that in the way the segments are named. Here's E to A, and here's E to B in red. And then here's E to C, and here's E to D. Again, those are pieces of the segment in blue. So part times part equals part times part. Right. So let's look at a couple of examples that use this part times part formula. So here it is, part times part equals part times part. So let's start with the segment here in red. The pieces here are 3 and x. So those are the pieces that I'm going to multiply together. I'm going to have this piece here is 3 times this piece over here is x. That's my part times part here. Equals part times part over in the blue segment is going to be, this part is 5 and this part is 9. So part times part here. And let's simplify that out a little bit. This is a pretty easy equation. 3 times x. And then over here we have 5 times 9 is 45. So when we divide, we're going to get 15 for x. Now, we're not done yet because it asks us to find the lengths of h to m and t to c. So let's do that. hm. Now that we know that x is 15, we know that this part is 15. So h to m, this piece here, this whole segment, 3 here and 15 here for a total of 18. And then it asks us for T to C, which is all the way across in the blue segment. I have 5 here and I have 9 here for a total of 14. So I do that to point out, notice that this theorem does not say that the chords are congruent to each other. That's not what is being said here. Right? This one's 18, this one's 14. What it is saying is that when I take the pieces that it's split into when they cross, those pieces, when I multiply them together, will give me the same thing. So here I had 5 times 9 equaling 45. Well, here I'm going to get 3 times 15. And 3 times 15, that's also 45. That's what we're saying is equal. Questions on that? All right. Let's do another example. This equation is going to be more complicated, but the idea and the formula is going to be the exact same. We are still going to do part times part equaling part times part. And we know that that's the formula we're going to use because everything is inside the circle. When we start getting things being outside the circle, we're going to use a different formula. But when everything's inside the circle, we're doing part times part equals part times part. So let me put this segment in red, and let me put this this chord in blue. We've got part times part in the red. My smaller piece here is x. That's not in red. X. And then my other piece is x plus 13. So that's my part times part for the red segment. Equals my part times part for the blue segment. This part, smaller piece here is the x plus 10. The other piece here is x plus 1. That is my part times part for the blue. Over here in red, I'm going to distribute the x across. We're going to do a lot of distributing on these problems since we're multiplying a lot of things together. This is going to start to get really complicated, and then it's going to simplify and get quite a bit easier. Okay, so it's going to peak and getting really complicated, and then it's going to get easier. So stay with me here. I have x times x. Anything times itself is squaring. That is what squaring is multiplying by itself. So 5 times 5 is 5 squared. X times x is x squared. Over here, when I distribute, I get x times 13. X times 13 here is 13x. That's the left side. Over on the right side, watch this one closely. This is the complicated part. We haven't done a lot of these because you didn't talk about it a lot last year. But this is still going to be distributing. Some of you may have learned it as FOIL, first outside, inside, last. But I'm going to talk about it as distributing. So I'm going to start by distributing the x. I got two things that I need to distribute. I need to distribute the x, and I also need to distribute the 10. So there are two different things I'm distributing. Let's start with distributing the x. If I distribute x here, I have x times x here is still x squared. Then I have x times 1. X times 1 is 1x, which I just write as x. That is my distributing of the x. Now we're going to do the same thing with the 10. We're going to take the 10 and distribute it across the x plus 1. If you're following as first, outside, inside, last, this is my inside and last. 10 times x. We're distributing the 10 across, so I have 10 times x is 10x. And then the 10 gets multiplied by 1. 10 times 1 is 10. Now I can combine some like terms here, so I'm going to do that very quickly. The main thing I'm going to do is I have an x here, a 1x here, and a 10x here. So I'm going to combine those together to be 11x. So this 1x and this 10x become 11x plus 10. Okay. We pause there. Do we have any questions up to that point? That's the complicated part. Any questions on how that got distributed or multiplied out? Okay, now it's about to get easier. Because first of all, I can subtract x squared from both sides. And those terms end up canceling each other out. And no more x squared. So that's good news. But I can make that even simpler, because the next thing I'm going to do is give everything with x on the same side. So I'm going to subtract an 11x to get everything with x over on the left side. 13x minus 11x is 2x. And I just have a 10 left on this side. And now hopefully it's clear what to do. We divide. And I get x to be 5. So let's do the same thing that we did on the last problem, which is it's going to ask us to find a to s and b to n, so the entire pieces here. A to s, remember we solved and found that x was 5. So wherever there's an x, I'm going to put 5 in. That's what's going to happen here. So x is 5, so this is 5. X is 5, so this is 5 plus 13 is 18. So if I'm looking for A to S, that's going to be a 5 here and an 18 here for a total of 23. Over in B to N, again, wherever there's an X, I'm going to put in 5. So over here, I have 5 plus 10 here is 15. Down here, I have 5 plus 1 is 6. So for B to N in total, I have 6 here, I have 15 here for a total of 21. Remember, what it does not say is that these entire segments are congruent. This is 23, this is 21. They're not the same. What is the same is if I multiply the pieces together. So if I take the 15 and the 6 and multiply it together, I should get the same thing as if I multiply the 18 and the 5 together. And I do. They're both 90 if I multiply those together. Questions on any of that? So this is all when we're inside the circle. When we're inside the circle, you're going to do part times part and part times part. All right, here comes the next formula, which is going to be when we are outside the circle. When we are outside the circle, this is going to become our formula. There are going to be two big formulas here. This is the first big formula was the part times part when we're inside the circle. This is the other major one, which is when we're outside the circle. Okay, scroll bars over here now. Fantastic. If two secant segments share the same endpoint outside the circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the outer secant segment. So product means we're multiplying again. But this time what we're multiplying is we're still taking the outer piece, so we're still doing a piece, but then we're multiplying it by the entire segment. So our kind of formula here that we're going to use is outer times whole equaling outer times whole. So on this one, the setups are going to be a little bit less straightforward because you're going to have to make sure that if you just have the pieces, that you combine to get them together to make the whole segment for that part of the multiplying. So notice that when I write out the segments, it's not e to a times a to b, which those would be the parts. That would be like outer times inner. It's e to a times e to b. E to b all the way across. So that's how we get it being outer times whole. So the outer part times the whole thing. So watching this example coming up, how we're going to combine things together to get the whole thing as part of our equation. Right? This time we're not just multiplying the parts together. We're going to do the whole thing.
What does that say,
Outer times whole. W-H-O-L-E. And same thing in the blue. Outer times whole equals outer times whole. That's going to be the formula we're going to use. Oh, x is really tiny there. Let me make it bigger. There we go. All right. So our formula, since we're outside the circle, it's going to be outer times whole equals outer times whole. Outer times whole on one of the segments is going to equal outer times whole on the other segment. Again, since we're outside the circle. Let's start with the red, and I'll make this the red. Outer. The outer piece here in that segment is 4. Right? That's the outer piece. That's the piece that's outside the circle. Times, not 6. We're not using 6 here because that's not the whole segment. To get the whole segment all the way across, this is the most common mistake I see in setting these up. We want the whole segment here. So I have a 4 here and a 6 here. That's going to be a total of 10. 4 plus 6. That's the whole segment. I want the whole thing there, not just the inner part. So I have the outer, which is 4, times the whole thing, which is 10. That's what goes on the left side. Equals. Let's do the same thing for the other segment. I'll give you a few seconds and see if you can figure out what the outer and the whole are going to be. Hopefully you're seeing that the outer piece here is 5 times the whole, which is not x. That's just the inner part. We want the whole thing, so we want all the way across here. This piece here is 5, this piece here is x, so we're going to combine them together to get the whole thing. So my whole is 5 plus x. And now we're going to solve. This one I'll do pretty quickly here. 4 times 10 is 40. This one we're going to distribute the 5. 5 times 5 is 25, plus 5 times x. And then we're going to solve. Subtract. That is 15. So then we're going to divide by 5. And when we do that, we get 3 for x. So that means that the whole here, the whole segment, is 8. So remember, what we're saying are the same is the outer times whole on each of the segments. Outer is 4 times the whole is 10 is 40. And then in the blue, now that we know what x is, outer is 5 times the whole ended up being 8. 5 times 8, hey, it's also 40. So on these ones, make sure that you are combining to make the whole segment on these ones.